Couple things before we get started. I think I indicated to you guys that we are I volunteered to be part of a pilot group to test a new course management system that will maybe eventually replace Blackboard that is being used on campus. And by me agreeing to do that, I basically volunteered you as well. So that's why we're not on Blackboard, okay? So I sent you guys an email, I think, last night. Did you guys receive an email from me last night? Basically, we're going to use something called Brightspace. So I wanted, and I'm not real good at it yet because I'm just kind of learning it on the fly. So it may not be like beautifully designed, but there are going to be features and functions in there that I know we don't have in Blackboard, and we're going to learn to use some of those together. But what I'd like you to do, and just make sure that we can do that, is go to francis.brightspacetrial.com is going to be the URL. So you're not going to, this course will never appear on Blackboard for you. It might be on Blackboard, but no, I don't think it'll ever be on Blackboard for you, right? You don't see it on Blackboard? No, okay. So if you go to francis.brightspacetrial.com, and you're going to come up to a login screen eventually, I hope. Okay, well, mine's already logged in. But your user ID is your email address. So it would be your, blah, 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 100 at francis.edu, abc100@francis.edu. You guys get this? And then your password is, and it's all capital, CPSC101 _1234. Okay, we'll get you in. All right. You guys able to? Were some people able to log in last night? Okay. All right. Anyone have any issues with that? So at this point, there's supposed to be all kind of features and functions in Brightspace that we can use. You'll notice the design is a little bit different than Blackboard right off the bat. It's kind of more, I don't know, social media-ish. It has tiles, those kinds of things. But our course should be the only course you have. It should be under Fall Management Information Systems. And it is loading. Okay, so you'll see the syllabus that we reviewed. The first class is under syllabus, course material, and I need to clean up some of this stuff because I'm not really happy with the look and feel of it. But under chapter 1, that's what we're going to talk about today. There's the chapter 1 PowerPoints. I'm not sure, the grades tools. I'm going to have to figure these things out as we go along, and so I apologize, but sometimes it's fun to learn something new and see if it's better than the old thing, and hopefully you will be surveyed at the end of the class as well to say, how did you like this compared to Blackboard? Because you guys currently have Blackboard courses as well, yes. So, any questions on that? So for now, it's just I have a conference call Friday with the Brightspace people. The sales people are trying to sell it to St. Francis. So they really want this class to go well, because if I make a recommendation and maybe we buy it, and it's X $1,000 a year. So anyways, they're going to show me some more things on how to use it, and it'll be better, I promise you. So any questions on that? Okay. Jeez, that was bad. All right then, we are going to move to the material, and your book frames chapter 1, and it talks about the importance of management information. Okay? Basically, it does a whole lot to tell you, hey, why is it important that you have this class? Okay, why should you be here? Why do you have to take this class? Probably most of you are taking it because it's a required course, not because, hey, I wanted to take this class with Dr. Miko. So it goes into a lot of detail about why we should study management information systems, why it's an important class in the business curriculum. And I want to just go through some of it, right? I just want to kind of touch on it because I hopefully you'll know at the end of the class that was an important class for me. So I don't want to kind of force that down out of your throats. But it talks about technology fundamentally changes business, right? Technology is a driver of business changes. You think about some of the billion-dollar companies that we have today that didn't exist 5 years ago, 10 years ago, 15 years ago, 20 years ago. You think about like Netflix and your Facebook and Pokemon Go, and just the kind of companies that have just appeared out of nowhere because technology. Uber, that technology drives business. And even a place like St. Francis, it's been around since 1847, and we're basically doing the same thing. I'm teaching students in a classroom. Think about all the technology that's fundamentally transformed what we've done here as well. So technology drives business, and that's why it's important for you to study. And we are living in what's called the information age, or the internet age, where controlling, producing, and understanding information is a big driver of the economy. It's not the industrial age. It's not it's not the agricultural age. It is the information age, where information is the important aspect. We're moving. The digital revolution kind of happened in the 70s. So there's a couple laws that we talk about. And these are like laws, and I just want to go through them a little bit. These are like people in the industry have formulated these laws and to show the impact of changing technology forces. And the first one, and this is probably the only one that if you've heard any of these laws, that's probably the one that you've seen, is Moore's Law. You ever hear of Moore's Law? No? You ever hear of Moore's Law? Yeah. Eric, what does Moore's Law mean to you?
Technology doubles every
Yeah, basically the way it was stated was Gordon Moore in the 1960s, okay, was the CEO of Intel. You guys know Intel makes like computer chips, right? Processing computer chips. And what he basically said, Eric, and that's kind of the takeaway from it, but he basically said the number of transistors on a computer chip will double every 18 months. Okay? And what that means, okay, that doesn't sound very great. That doesn't sound very sexy. But what that means is the price-performance ratio is unbelievable. It has changed, it changes every 18 months, and it doubles every 18 months. Think about that kind of growth, exponential growth. If you doubled in size every 18 months, you would be a giant, right? If we applied that same growth pattern to the car industry from the 1960s, think about cars in the 1960s, and think about cars today. They still run on gas, they still go about the same speed, they still get decent gas mileage, they still cost, considering your how much you make, about the same part of your income. Do you know what I'm saying? If we applied that to cars, if we applied that same growth pattern to the automobile industry, you could drive from Pennsylvania to California in under 10 seconds. A car would cost a penny. It would run on a thimbleful of gas. Do you know what I'm saying? Like the way the computer industry has doubled every 18 months, if we applied that to another industry, it'd be unbelievable the change you could see. So that was Moore's Law. Okay? And what that means is the price-performance ratio has changed so that we can get more technology for our money. And this I still might be dating myself here, but do you guys remember when flat screen TVs came out? You guys know what I'm talking about? Like when your parents probably got rid of a big cathode ray tube TV, you know what I'm talking about? And when those first flat screen TVs came out, you guys know what they cost? Like the first ones, like a 30-inch one, a 31-inch one. You know what they cost? Like plasma was the technology. You guys remember that? What do they cost?
They're really super expensive.
Yeah, like $5,000, right? Oh, I got a flat screen TV, and that was like, wow, it's $5,000. This was only a few years ago. And now, if you look at like Walmart flyers and stuff, you can get a flat screen TV for like a couple $100, and it's much better quality. So that's what happens with anything technology driven, right? In just a few years, what was very expensive and what was very limited in performance becomes cheaper and cheaper and cheaper, and the performance increases along the way. That's what Moore's Law tells us happens. Okay? The other laws are similar. One is called Metcalfe's Law, and what Metcalfe's Law says is that the value of a network, okay, is exponential or squares based on the number of people on the network. So If n is the number of people on the network, we square that, we say that's the value of the network. And it's kind of an artificial scale. But if you think about it, if we have a network and it's just me and Will on that network, well, me and Will can share information, and that has some utility to it. But then we put Rando on it, and Taylor on it, and Catan on it. Now, the usefulness of that network just increases. You think about something like eBay, like an auction site like eBay, right? eBay is so useful because there's almost an infinite amount of buyers and an infinite amount of sellers coming together to make a perfect market. So Metcalfe's law says, hey, because we're able to network things, we're able to increase the value of it. The other two laws aren't as common. Nielsen's law talks about network connection speed. It increases by 50% every year. And what does that drive? What does that change? How does that change things? The network speed changes, goes up 50% every year. What can you do now very easily that you couldn't do 7, 8 years ago in your home? You couldn't stream video like you can today, right? You could maybe stream music, you could maybe download pictures. You couldn't stream video, things like that. You couldn't download high-end things just 7 or 8 years ago. And Kreider's law talks about the storage density, like the storage power. So, MIS, because it grows at such a rapid pace, it changes the way we do things. It changes the way we do things, and not like say, okay, it's going to change in the next 10, 20 years. The way we do things changes rapidly. So in the business world, if you don't understand technology, you can't adapt to changing technology, don't understand what new technology changes will bring to your industry, you're going to suffer. You're going to fall behind. So that's why we study management information systems, in this class. Okay. So let's go back, and that's why MIS is important. Let's talk about define what MIS is. MIS is kind of a tough discipline to recruit for. Okay? I say recruit for, I mean recruit majors coming into an undergraduate program. And the reason for that is most high school students have never heard about MIS, let alone majoring in MIS, right? Because even our admissions counselors, when I talk to them, I say, do you even know we have MIS? Right? Yeah, it's something in business. They don't know what it is, right? They don't understand what MIS is. They understand what computer science is, like they think some programming, but they don't understand what MIS is. So let's start at the basics. MIS is an acronym for what? What is MIS an acronym for? Let's take it a piece at a time. What's that an acronym for? No. First one is okay. So let's think about management. Some of you are business management majors. What's that mean? What do managers do? What is management about? Come on, what is management about? Being in charge, okay. So when you're in charge, you can just be in charge. I'm in charge here, I'm king of the hill. But what is the action? I'm trying to think of the actions that if you manage, what are the verbs that are associated with management? Go ahead.
Making decisions.
Okay, making decisions. That's good, right? Making decisions. I like that a lot. Managers in the business world, we have finite resources, we have finite time. We have to make decisions, right? Based on, we have constraints. What else do managers do? Make decisions. Very good. What else? What else do they do? Yes. They lead, right? They set direction, right? They plan, they forecast, they organize, they change all those things. Think about management, a very general thing. I can manage the School of Business faculty. I can manage, I can't manage, but I could be the general manager of the Pittsburgh Pirates. I could be the manager of a Fortune 500 company. I could manage a cake shop. I could manage, all kinds of things. It's a general skill, right? It's kind of hard to define, even though we're studying it. Management is a general thing. Okay, so that's what management is. I like thinking about what managers do because that helps you define and think about what management is. How about the second letter? Second letter is what? Maurice, what's the second one? Yeah, information. Okay, information means what, Maurice? What is information to you? Because this is one that even though it's so important, it's hard for people to define. What is information use?
Stuff you're working with.
Okay, the stuff you're working with. And how do you use information, Maurice? Give me some information that you use. Anything.
Like data and stuff.
All right, very good. So, and I use this exact same little cycle yesterday in Stat 301, okay? Think about data, right? Data is just raw facts. Data is, you know, everything we're producing all the time. If you went down to Adamuji this morning and bought a cup of coffee, well, that produced data, right? That produced data that said, hey, take this off their balance, you know, or maybe use a swipe card or a credit card, you know, that was data. The inventory system down at Adamuji's changed, right? Everything we do generates data, okay? Everything we do generates data. And what we want to do with that data is just raw facts, is we want to create information. You know, we want to analyze that data, we want to aggregate it, we want to summarize it, we want to, you know, apply statistics to it. Why? Because that gives us information, and information leads to what? Knowledge, okay? And knowledge is power, right? Sir Francis Bacon said that. So you think about it as a manager, okay? As a manager, I need to decide things. What helps me decide things? Information, right? Should I go with option 1 or option 2? Well, you know, I'm not just going to guess. It's not a random thing. I'm going to look at the information supporting option 1 and option 2. Do we need to order more coffee down at Adamuji's? Well, let's see how much we sold. Is Adamuji's profitable? Let's see what total sales were. How much do I have left on my declining balance card? Well, this is all the things you bought, right? All that kind of stuff is information, right? All this data generates information. So management, information, and the last one. What's the last one? This is also a general kind of word. What is the last one? Systems, okay? Ricardo, right?
Yeah.
You a part of any systems, Ricardo? Do you know a good definition for systems? Give me a definition for system. You a football player, Ricardo?
Yeah.
Does your coach have a system? What do you play, defense?
Yeah.
The coach has a defensive system, right?
Right.
What does that mean?
Like the strategy, right?
Okay. And the definition that we hear like in, somewhere like in 7th grade biology, ever hear an interrelated set of components working together to get something done? You ever hear that definition? An interrelated set of components working together. So your defense is an interrelated set of components working together to get something done. Is it not? You have linebackers and defensive ends and cornerbacks. If you think about all the systems in our body, we have 7 of them. They all work together, like your digestive system has components that work together to get something done. So systems, generally speaking, and it's very general, right? We can have a digestive system, we can have a defensive system, we can have a system for the way we do things. A system is just a bunch of things, components, working together to get something done, right? So if we look at this, right, that's difficult because we have 3 words that are kind of nebulous, kind of hard to define on their own, is it not? Management, we said, well, we know kind of what managers do, but it's kind of hard to define what that is. Information, I kind of know what information is when I see it, but it's very general kind of concept. And systems, we say another general concept. But if we take those 3 words together, okay, if we take those 3 words together, what do you think MIS is then? What do you think MIS systems do? What do you think MIS systems, and it's really kind of, even when we're going to define it, we're going to define it too narrowly. What do MIS systems do? Think about those 3 things we went through. What do you think MIS systems do? Think about systems, information, management. What do MIS systems do? Take those 3 things together. So what are systems? Systems are interrelated components working together to get something done. So what do you think the interrelated components of an information system are? Nothing. All right.
Okay. They could use that as a
Okay. I like that. Not you, but you, the business professional, right? So you think about it. We put together systems, right? Information, not just systems, information systems. Systems predicated on taking data, creating information, so we can do what? So we can make better decisions, so we can plan, so we can organize, so we can forecast, so we can report. Think about all the things management does in general. Well, something needs to support that function. Information needs to support that function. Technology systems, interrelated components working together help us do that, okay? So it's kind of a hard thing to define, is it not? It is a hard thing to define, but what it is, everything that supports the function, okay? The function of management, okay? So if we talk about it, it says the key elements: manage and use information systems to support strategies. Managing IS to achieve business strategies. Very, very general, right? We can have systems to pay people, we can have systems to recruit people, we can have systems to procure inventory, we can have systems to sell things, we can have systems to keep track of things, accounting information systems, we can have systems to incent people, right? There's all kinds of systems, very generally speaking. When we want to study something, okay, sometimes when we're trying to study something that is kind of hard to define, kind of nebulous, kind of can be a little complex to think about, what we do as educated individuals is we try to break it down, right? We try to look at it through a lens of some kind of criteria. And we're going to do that today, okay? We're going to try to do that today. And we're going to look at it through a couple different lenses. And the first one is we're going to use like a systems methodology to look at any system, right? Any system that there is. And then we're going to try to apply that to information systems. Every system has a purpose, okay? Every system has a purpose. A system has a purpose, and the purpose is why the system exists. What is the purpose of this system? Every system has inputs, things that come into the system, right? Things that unprocessed things that come into the system. Every system, if it has inputs, what else does it have? Because it has a purpose. It has outputs, right? It has outputs. And if you have a system that has only inputs, which really shouldn't be, and we design things and we try to analyze things, if it has only inputs and no outputs, we call it a black hole, right? Because we're missing something, right? And black holes, kind of exist in the galaxy, but they don't really exist when we're talking about information systems. And if you design something that has only outputs but no inputs, they kind of call that a miracle, right? Because that shouldn't happen either. So every system has a purpose, it has inputs and outputs, and the last two are kind of related. It has a boundary, and outside its boundary, it has an environment. So let's take a look at something, a system. Let's take a look at something as a system and try to break it down, because we want to study it into its 5 areas. So let's think about the School of Business undergraduate business program as a system. Okay? Let's think about St. Francis undergraduate business program as a system. It's called systems thinking about things as a system. So let's think about the undergraduate business program as a system. What is the purpose of the system? What is the purpose of the system? The undergraduate business program. Okay, that is our purpose. And in fact, we have in our mission statement, I don't even know our mission statement, but we have a mission statement that this is our mission, right? To educate students, to shine the light of knowledge in the darkness of ignorance, right? That is our mission, yes? So inside, okay. So inside the system, we have a bunch of folks. You know, we have me, we have just various people, right? We also have classrooms, we have Schwab Hall, you know, we have curriculum. All those kind of things are inside the system, right? What comes into the system? Well, if we said what are our inputs, what are our inputs to the system? Very good. What kind of students? Very undergraduate students, high school students, transfer students. So I'll try to put a little backpack on this person, right? Okay. And they come into our system, you know, hopefully at one level. And what is our output? Graduates, right? So same person, but hopefully inside you, you've changed. You know, hopefully things have changed. So I'm gonna, you know, put you with a little briefcase, all right? So backpack to briefcase program, right? So uneducated students, out-educated students. That's what we're trying to do. So what's the boundary and environment of this system? What's the boundary and environment of this system? The environment are things outside the system that can affect the system. Okay, for example, what? Well, let's say the federal government came down with regulation that said, you know, to earn an undergraduate degree, you have to have 150 credits. Well, that would change our system, right? If they said, I don't know, you have to have, every student has to have, but anyways, if there was regulation that changed the way we had to educate, that would change our system. The federal government is not inside our system. They're in the environment, they're outside our boundary, but they can change the way we do things, right? If you think about it, even things in St. Francis University, if IT services said, hey, we're getting rid of the laptop program and going to an iPad program, that would change the way we do stuff inside our system. They're in their environment. Does that make sense? They can do things that affect our system. Okay, so we can break things down system-wise, right? System-wise. The other way we can do things, okay, is we can talk about 6 functions. And this is really related to, this is more general systems thinking, and this is really related more to a information system. Okay, 6 functions of an information system. So 6 functions of an information system, and I have a little slide out here, are these 6 things. Every information system has to support these 6 functions. It has to be able to capture, transmit, store, retrieve, manipulate, and display data. Okay, so think about an information system. Let's think about that input. Information systems need to capture data, capture information. How do they do that? Give me one way an information system captures information. Go ahead.
Data stored on a hard drive.
Okay. Well, yeah, but how does it get in there? You're right, but how does it capture it from you? How do systems get data into them? And they store them. You're right. That's going to be a function, storing. But how do they capture data? Give me one example. Okay. So you're generating data by like typing, right? Clicking on things, swiping the magnetic card, talking. Right? I'm generating data right now as I talk. You know, if you're generating data just by walking around, just by being on a network, right? So you go to the ATM and you punch in your PIN number, and it's capturing data with that PIN, that keypad, right? When you swipe your card, there's a magnetic card reader that's capturing data that way. So when you think about hardware, the keyboard, barcode scanner, document scanner, optical character, sound recorder, video camera, voice recognition software, motion detectors, all of these things are capturing data into information systems, right? All of these things are capturing data. I'm not wearing my Fitbit today, but that's capturing information every step I take. Yes, right, it is. Okay? So every information system does that. Every information system has to be able to transmit. right? So capturing is important, but it has to be able to be moved somewhere. And if we think about transmission, it can be as simple as you say, well, like, I type it in, I click save, and it transmits it to the stores it on the hard drive. That's like a short transmission, right? But what's great is with modern network technology is we can transmit data around the world and back in a matter of milliseconds, right? You can be texting or instant messaging someone in China, just like you can instant message me in my office, right? So we can transmit through networking technology, broadcast radio, whatever, broadcast TV, cable TV, network, data transmission network, all these things can move data various places. The next two are kind of related. Information systems have to be able to store and retrieve data. So you mentioned hard drive, right? Another way we can store data is print it out and read it, right? That's retrieving the data. We can store it on flash drives. We can store it on optical disk. We can store it on, a floppy disk, computer tape, paper. There's a lot of ways we can store data. Magnetic stripes, right? So wherever we store it, we need to also be able to retrieve it. Those two functions are related. The next one is manipulate. What do you think manipulate means? What do you think manipulate means? What do you think manipulate means? Yes, sir.
The ability to edit.
Yeah, to change it, right? Like when we think about data, we have all your grades, right? Well, we want to figure out a grade point average, so that's going to take like some manipulation to do that. We have to add up all your grades, convert the A's to 4s, the B's to 3s, add it all up, divide by how many courses you take. That's manipulation, right? If you think about it, that's what happens inside the information system. There's software that drives that process. Those manipulation. Programmer said, I want you to manipulate the data this way. And then the last one is display. So display is obviously, because we're interfacing with a human, we need to display it somehow. So display it on a computer monitor, print it on paper, some kind of virtual reality deal, some kind of Oculus Rift, but we need to display it. Okay, we need to display it some way. So if we think about this, these are information systems. We can kind of tie a lot of this back, right? We can tie a lot of this back to, capture would definitely be inputs, display would definitely be outputs, store and retrieve, not so much, but manipulate, really what the system is doing, right? What the system is doing, what the purpose of the system, when we're manipulating it, what the system is doing. So these are two that I use, but I want to get to what the book uses. Okay, this is the 5-component framework that the book talks about. And then we're going to try to analyze, using these frameworks, a couple information systems. The book says when we talk about an information system, we want to look at it through the lens of 5 components. Hardware, software, data, procedures, and people. I think you guys know what hardware is. What is hardware? What is hardware? Yeah, so physical stuff, right? Like the hard drive, like the video camera, the keyboard, physical things, like objects, right? That document camera, that monitor, hardware, right? That hardware. What is software then? What is software then? What is software? Yes, Kyle?
Like the program that's on the.
The software tells the hardware what to do, right? Operating system software says, hey, show this on the screen, run this program. Application software says, hey, this is it, do this, right? Software is programming language. It tells it what to do, okay? Data, if you think about it, is just that. It's the data that's part of the system, right? Whatever it might be. We're talking about ATM system, like an automated teller machine. Your PIN numbers, the data involved, your balance, all that stuff is data. P is procedures, right? Procedures is how do we interact with this? Okay? And sometimes we need trained to use an information system, and sometimes it's pretty damn intuitive, right? You probably never had to receive a training to use the MTO ordering information system, did you? You kind of figure that out. It's very intuitive, right? Like, I want a hot dog, so you just mark out, right? Pretty easy. Now, some information systems aren't that easy, right? You need training, okay? So you have to learn the procedures to use the information systems well. And then finally, the last piece, the most important component of an information system is people. Because when we talk about an information system, we're not just talking about the hardware, the software, the physical computer things. We need to talk about everything that makes it come together, including the most important person, the person using the information system. Now, what's beautiful about this 5-component framework is we can look at it and it has a couple things going for it. If you notice, on this side, hardware and software are both what? They're computer side, right? That's things, the computer area. The right side, procedures and people, that's the human side, right? That's us. That's what we do and who we are. And the middle is the data, right? That's the thing that kind of binds it together. And if you look at this, there's some symmetry to it as well. For example, software tells hardware what to do. Software is instructions for the hardware. Procedures are instructions for the people, right? So there's some symmetry there. So software and procedures are instructions, both are instructions generally speaking, and actors, the things that do something in an information system, are us and the hardware. We're the physical items, right? We're the things that do things. And what we're trying to do when we install information systems, generally speaking, is we're trying to do what? We're trying to push work from us to them, right? From our side, from the people side, to the computer side. Okay? From our side to the computer side. We're trying to say, this is something I used to do myself, but I'd rather the spreadsheet do that, right? I would rather this transmit that information than me walk it over to the registrar's office. I'd rather email do that for me, whatever it might be. Yes? Yes. The other thing that we see is the more we go this way, the harder it is to change things. If this breaks right now, IT service could be over here in 10 minutes and swap a new one in. That's an easy change, right? If your mouse breaks, I'll put a new mouse in. Easy change. People. Try to change someone in a bad relationship, try to change someone. People are hard to change, right? People are very difficult to change. Everything on this side, harder to change. Everything on this side, easier to change. So why do we do this? Okay, why do we do this? Because when we're studying something complex, it helps us by breaking it down into various components and understanding what we need. How these things interact, how these things come together. So let's take an example, and I'm going to make you do an assignment here eventually. But let's take an example of, I use the MTO ordering system. That's a great system, is it not? It's a fantastic system. The MTO ordering system. Let's break that down all these ways. Okay, let's break that down using systems approach, using functions of information systems, and using the 5-component framework. You guys are going to help me do that. So, Ms. Noel, right? What is the purpose of the MTO ordering system? All right, so you need to communicate to that person back there, this is how I'd like my hoagie to look, right? That is the purpose of that system. What are the inputs to that system, Ms. Noel? What are the inputs to that system? Okay, so what you type in, right, those are inputs. There's some kind of pricing file. Someone also has some kind of file of the options, right, that was loaded in there to the system. Those are all inputs. How about outputs to that system? I'll pick on someone else. Will, what are the outputs to that system? Okay. Yeah, you can say the food. What else are the outputs? Your food is the output, you're right.
Receipt that it's given workers.
Okay, there's a receipt, there's something transmitted over to the other side so they can see what the hell you're making, right? Those are output, what they're going to make you. Those are outputs. There's an output that sends it over to the point of sale system so that when you go over there and say 356, they say, oh, 356, you ordered a blah, blah, blah. So it costs $4 or whatever it might be, yes? And what are things in the boundary and the environment of that system that can change things in that system. What can change things in that system? What's outside the system that can change that system? What's outside that system that can change that system? What do you think? Yes? Okay, so, I mean, it's a bad example, but we say you can no longer sell those sheets hot dogs because there's so much arsenic. Something like that, right? We have to change our system, yes? They change a tax rate or a food preparation rate, yes, that could change things, right? If if marketing decides, hey, we're running a special, right? We're running a special, it's 3 hot dogs for $1, that changes our system, right? It does, okay? It very much does. Let's look at that functions of an information system. Let's look at the same damn system, but now let's look at the functions of that system, okay? So capture, how does it capture? Aubrey, right? How does it capture information? That's one of the beautiful things about it. And how does it capture it physically, though? How do you interact? How does it capture your you don't yell over the counter like, give me 3 hot dogs. How do you do that? Yeah, it's a touch screen, right? That's the capture mechanism there. It is. That's the capture mechanism. Transmit. What is transmitted? Sorry, what's transmitted?
The order.
Yeah, the order is transmitted right from you typing in here to the back, to the point of sale system, probably to some other sales system at Sheets, so they know, globally how much was sold. That stuff guaranteed is stored, somewhere in the Sheets premises or a server somewhere, right? All those orders, all that generated data can be retrieved later. I mean, I ordered a salad this morning for lunch. I bet you I can go back there and say, what was order 452, and they could find it, right? They could say, at 8:36 a.m. you placed this order, right? They could find that. They could retrieve it. Manipulate. What do you think manipulate is? So how about manipulation? What kind of manipulation do you see there?
Would that be when they mark it paid for? So
Okay.
They can give it to you?
Sure, right. They manipulate it. There's a paid flag that marks it paid. There's manipulation when it says, the software says, well, think about the branching logic the software uses. You selected here, now I'm going to display this screen. That's software driven. And display, what are the things that are displayed out of that system? So obviously there's a display. Over the other side, it looks like they have a little screen that shows you what they ought to make. You know what I'm saying? Like the computer screen. There's a receipt that's printed, right? That you get. So there's multiple display mechanisms in that MTO ordering system. Now let's think about it through the lens of the 5-component framework. And there's a lot here. Hardware. What's the hardware? What hardware do you see? What hardware do you see? Mr. Boyd, give me some hardware you see there. Yeah, that kiosk, right? That thing, right? It has a computer screen, it has a computer in there. There's networking cables, I'm sure. I don't know if it's wireless, but I think it's connected back to that other computer screen back there. Very good. It's being transmitted somehow. Software, someone had to design that, right? Someone had to design the software that's being used, the mechanism, the drill down. Someone had to design that, hey, this is going to interface to the point of sale system. Someone had to write code for that. What's the data? By the way, data in systems doesn't change a lot. Hardware changes, software changes, data doesn't change a lot. What's the data? What's the data? Yeah, the menu items, tomatoes, ketchup, all that is the data. 6-inch, 12, that's data, right? That's all that is data. Procedures, what? What are the procedures in that deal? What are the procedures in that deal? Procedures are steps to order. There are procedures you have to go over here and pay. There are procedures on the back end that, hey, this is how we get to orders. We do them in first in, first out form. There's procedures that take place there. You said, hey, you don't give them their sub until they pay. That's part of the procedures in that information system, is it not? Yes, it's part of the procedures. And then the people involved in the information system are the customer, the MTO maker, the point of sale person, the checkout person, right? All those things. Now, why do we use this? Well, if I was trying to put in an information system, think about it. If I was trying to say, I'm going to take this business process and automate it, I need to think about all these things. I need to think about what's the hardware going to be? What's the software going to be? What's the data? how are we gonna train the people, what people are involved? So if you're a business professional and you're either changing an information system, putting in a new information system, it makes sense to look at it and break it down into its elements and analyze it that way and make sure those are all handled and all accounted for. It's probably a good breaking point. So what we're going to do, we're almost done with chapter 1, believe it or not. Because chapter 1 has a lot of fluff in my opinion. So what we're going to do Friday is I'll give you a little mini assignment on doing the same thing we did with the MTO ordering system. I'll probably give you like different systems, like someone will get a payroll system, someone will get like an ATM system, someone will get Netflix, you know what I'm saying? Like we'll give you different information systems. I'm also going to do, remember that ongoing article presentation that I haven't set up? I told you guys about on Friday. I will do a couple, like I'll show you what I would like done for those, okay? And then we'll probably finish up chapter 1. That's our game plan.
We're gonna do the assignment in class.
I don't know that. Yeah.
You're gonna send us an email.
I'll tell you Friday.
Okay.
Yeah. Have a great day. Yeah, it's not going to be due Friday.
Okay. Thank you.